Hi, I'm Brett, and today I'm going to show you how to synchronize two devices using DAC-MX and LabVIEW. Now, to run two devices as if they're one, you need to synchronize or share two different clocks, a start clock and a sample clock. And these clocks need to be shared externally, physically linking the two devices. Now, in some situations, you may have boards inside of your desktop PC. These devices can be linked physically using a cable internal to the PC, known as a RITC bus. But for today's situation, I have two different devices on the desk here. One is a USB MIO device. The other is a USB compact DAC chassis. And I'm going to synchronize these two devices using standard BNC cables. Now let's look at the software and see the test system that I already have set up. Here I have a VI running an acquisition from one of the devices. This is the USB M-Series device. And you can see I'm hooked up to a function generator, so I can modulate my amplitude. And let's go ahead and look at the code. You can see I have a simple DAC-MX task set up using the API. But now let's say I want to expand my system and add the compact DAC chassis to it. To do this, I'm going to simply highlight everything, hold down the control key, and effectively copy one task into the other. Now, because both of these devices use the same driver, changing the address from one device to the other is as simple as selecting from a pull-down. So I'm going to take my DAC-MX channel device pull-down and change it from device 1, which is the USB M-Series device, to compact DAC 1, module 1, AI 0. Now if I hop back over to my front panel, I'm going to go ahead and move my stop button out of the way and clean this up a little bit. And if I run this, you'll see that both devices will run, but they're out of phase. And that's because the devices started at a different time, and they're running on their own internal clocks, which are not going to be in sync. So now what we're going to do is we're going to go back into software, and we're going to set up the DAC-MX tasks to where they can share these start and sample clocks externally. I'm going to start by giving myself a little room on the block diagram. So if I hold down the control key, left click, and just kind of drag myself a nice large window, that'll give me some space on the block diagram to work. I'm also going to go ahead and delete some of these wires in between, giving myself a nice empty spot in the middle where I can add some new functions. I'm going to open up my DAC-MX data acquisition API palette. I'm going to go down into the task palette and grab an export signal VI. Now the export signal VI is going to take the start and the sample clock from inside the USB M-Series, and it's going to route it to one of the BNC connectors on the front. And in this case, I'm going to use PFI line 0 and PFI line 1. And these are specially digital lines that were built specifically for triggering another type of external communication. So I'm going to start here, and I need to create a constant on the signal input. And you can see that the default is sample clock, and that's good. Now I need to route this to a physical terminal. And for the sample clock, I'm going to go ahead and do PFI line 1. Now remember, we're coming out of the USB M-Series, so I have to go down to device 1 and select PFI 1 on device 1. So there you have it. Now since I have two clocks that I need to export, I'm going to go ahead and highlight this and do the hold down control copy again, slide it over. And now all I have to do is change my options. I've got the sample clock, so now I want the start trigger. And then, since I've already got PFI line 1 engaged, I'm now going to slide this over to PFI line 0, and I can go ahead and connect this on through. So now the software is going to tell the device to route its internal clock signals to an external pin. So now how do we get that to the other device? Well, we go back to that BNC cable that I talked about earlier. We use one cable for PFI line 0, and you can see this is connected to line 0 on the CDAC chassis, so I connect it to line 0, PFI line 0 on the USB. And then the other one I have connected to line 1 on the CDAC chassis. And we will go ahead and hook that up real quick to line 1 on the USB MIO device. So I have one for my clock and one for my start trigger. So now that they're physically connected, we have to go back in software and tell the compact DAC chassis not to use its own internal clock, but instead to use a clock that's coming from an outside device. Now, for the CDAC task, you can see that the sample clock is already an import terminal on the sample clock VI. So I can just right-click, go to Create Constant. I'll go ahead and move this up so I can see it. Let's see, what is this? This is going to be the sample clock, and the sample clock again was routed to PFI line 1. So this time I'm on the receiving end, so I choose CDAC1 PFI 1 because it's the input. Now I can go back to my DAC-MX palette because I need to input a start trigger. So I go ahead and grab the trigger VI for the DAC-MX API, select Digital Edge, and I now have, again, a source terminal to which I'm going to create a constant, and my start trigger is going to be on PFI line 0 of CDAC, because again, we're coming into the CDAC chassis. So I'm going to go ahead and connect this on through. So now I've told my MIO device to output its start and sample clock, and I've told my compact DAC chassis to input a start and sample clock. The last thing I have to do is make sure that the compact DAC chassis is enabled first, so it's ready to receive the clocks as they come in. To do that, I'm going to use a structure in LabVIEW called the flat sequence structure. And you can kind of think of this like a comic strip, where it's going to read one frame at a time. So I'm going to create 2 frames here, and all I'm going to do is drag the start button for the compact DAC task into the first frame. Go ahead and get rid of that. And I'm going to grab the start task for the USB for the origin of the clocks, and I'm going to make that one go second. That way, CDAC is ready to receive, guaranteed, when the USB device fires. And now it's just a matter of wiring these through. Now in this situation, I'm just using one channel on each device. I could just as easily be using every channel on each device. The compact DAC chassis can actually acquire up to 256 channels with 8 modules installed. So you can imagine, of course, one of the reasons for needing a second device is to have more channels. So if I just need to expand my device, you can see in this short time here, we've been able to do that because of the DAC-MX API and because of just the inherent ability of LabVIEW to copy code. All right, one last thing I'm going to do is I'm going to use the cleanup block diagram tool, and that'll just kind of clean up my block diagram and make it easier to read and look at. All right, so now I'm going to go ahead and switch back over to the front, and now when I run this, you can see that both of my waveforms are acquiring, except this time the peaks are lined up. The 0 crosses are lined up because they started at the same time and they're acquiring at the same time. So you can see that as I modulate my frequency or my amplitude, if I slow it down a little bit here, you can see that they're in perfect alignment because they're using the same clock. And that's how you synchronize 2 external devices using DAC-MX and LabVIEW.